So like I was saying, I was just reading the intro for you that each session will blend theoretical frameworks with practical case studies, encouraging you to question established paradigms by the fathers of philosophy, those who started arguing. There was a time they said the whole world was flat. And those who believed that the world was flat also came up with another group came up with another concept that the world was spherical. And this thing degenerated into to the extent that people were even killed. You understand? For questioning, those. So, we evolve as and when new knowledge, comes out. But I just want to draw your attention to something. You see the phones we use today. We used to use phones that were 4 meg, right? And we were taking pictures. But today we're using 16 pixels, 32 pixels. That gives clearer image. So if we're using microscope and we're viewing the world with 4 meg, and today we have 16 even pixels, what it means is that we might see things clearer. So what we are holding now as the best, as time evolves, it's possible that what we might think that things were are not going to be the same, let's say from 20 years from now. Probably we might see things clearer. So that is why in research, we keep discovering and we keep refuting. Because somebody might use an instrument to measure something. They might have issues with the instrument in terms of validity and reliability. Another research will come and use a more robust instrument, might get another finding. Another one will come and then dispute that same instrument. We used to say that, okay, drink more water. Another research has come and said, who said that nonsense, that we should drink more water? That is actually not correct. And they come out with different theories. So the reason why we have to, as PhD students, what we are doing set with philosophy of science is the fact that we are in a journey of inquiry and we do not stop. There is no definite, destination where we say we have arrived. So we keep questioning the status quo. And like we said, it will also help you to develop your own philosophical position. That's why I'm interested. Now, there was a guy called Karl Popper who developed the theory of falsification. I read about him extensively, and I decided to be like him. Why? Even though he was crazy, he says that every theory that is that robust, we should be able to falsify it. And if it stands to the test of time, then it means it's a good theory. That's what, Karl Popper said. But the negative part of it is that, so if a theory is not falsified, then it means it's not a good theory. And that was what the kind of argument they used against him. Okay. He migrated from a group that they call the positivists. And the positivists believe that knowledge can be acquired through verification. That if we believe that God exists, we should know him. We want proof. Then this guy is saying that I don't need, if I have 10 mangoes and they are all red, I don't need another 11th mango which is red. I only need one white mango to disprove that all mangoes are what? Red. I don't need to worry myself. And that's why Papa moved from them and decided to, he said, if we cannot falsify your theory, then it means your theory is not what strong. So we'll be building our own perspective. Either we want to be the relativist who believe that knowledge can be acquired through reasoning, that common sense, they are the common sense people, say that, but you, as you live, you don't know that the air we breathe comes from somewhere. And the fact that you don't know where the air is coming from, you don't need proof to know that God exists. They believe that is the, relativist. Okay, and they believe in the moon, the stars, astrology. They can tell your destiny. They believe in those cosmic bodies because by reasoning, you should know that, God what exists. Okay, so we will be looking at the foundations where we will examine the nature of science. What is science? We need to understand what it is. And then scientific method. And when we say we are doing methodology and the methodology is scientific, what does it mean? Okay. And let's see here. Yeah. The demarcation problem between science and pseudoscience. Pseudoscience is what? Fake science. Do you understand? It is not true, science. And then Karl Popper's falsification and logical positivism will be the central to our discussion. The two scientific progress will explore how science evolved through Thomas Kuhn's paradigm shift. Thomas Kuhn, another good, philosopher. He had also his own. And then you have the Lacato's research work programs, and then also the ongoing debate between science, realism, and then instrumentalism. Okay, realists are like positivists. When somebody says that I'm a realist, what is telling you is that, Charlie, me at the sea before I believe. You understand? I want things, tangible things. I don't want abstract. Realists are just like that. Then the final day we address social and ethical dimensions of science, including the feminists and then also the post-colonial critiques and those who criticize this positivist and relative, and then institutional power dynamics and also ethical responsibility of science. When they say feminists, including feminists, you see, this issue about the history was actually something that was coined to bring down, feminists, because it could have been her story, not his story. You understand? So where is the her story? Because women in history have demonstrated that they are actually nation builders, but they talk about his story. That is history, but not her story. So that's why they are saying that, this thing including what? Feminists, okay? Issues that because they have to tell their own story. So that's why it's started. And then now, that affirmative action, they have passed the bill in Ghana that deliberately women should be part of what? Governance and all that. Actually, if you ask me, I don't support that. Reason is that women, when given that same opportunities that men are given, they understand, will even do better than them, men. Because in class, most ladies, regardless of their cycle and then this, pressures that they go through, most of the classes that I've handled, over 3,000 Coventry students, most times the women who come first. All right. But if you look at the whole architecture, laws are built based on this to favor for men and also to favor men. So then women have their own issues. So we'll be looking, then we'll also look at pedagogy approach to the learning of this. So we look at critical dialogue, case studies, and then reflective word practice. These are the approach. So what is science? What is science? There are three things that comes to mind. I've given you the, but I want you to put it on your laptop, if you can open it on your laptop. So science. So science is a systematic what? Inquiry. When we bring in system, what we mean is that it follows a certain structured approach, okay, into inquiry or inquiry. So science represents humanity's most rigorous attempt to what? Understand reality through systematic what? Observation. So in science, we want to understand things that are around us. And once you begin to think in that perspective, then you begin to ask so many questions that where does the air come from? I mean, who is born? How come we were given birth? Then you begin to inquire and want to find out, okay, this story about religion, is it really true? And you begin to inquire. So that is what is going. The good part of it is that as a PhD holder, sorry, let me. Now, so you can come. We are here. If you want. Oh, okay. Then let's talk tomorrow. Okay, no problem. No problem. Yeah. So we want to. Yeah. Oh, because of what? Your battery. Okay. So because we want to find out why things are the way they are, we begin to inquire. And that is the good aspect of science. Okay. This thing about this economy, where I'm even surprised still, people are still looking at borrowing. We are still borrowing. And then you want to find out that, so can't we have any other way to solve our problems rather than following that same paradigm? Because that is the easiest way. You get it? Nobody wants to come out with creative thinking or any other way, but actually, people think that in reality, when you want to take decision, you have good, bad, and then neutral. But that's not it. Because if you take the bad, there are about 1 million instances that we can create in the bad. If we take the neutral, there are 1 million instances. And if we take the good, there are 1 million instances in the good. You get it? So it gives us the opportunity to expand. But it is not so with our daily life. So if you are a real PhD holder and you really want to demonstrate that in your discussion and argument, then you want to find out why things are the way they are. You don't sit in a meeting and somebody will mention an abbreviation and you keep quiet. You are doing that at your own detriment. You understand? Because you need to understand. Find out, what do you mean? ABS, what is it? You want to know. You get it? So always asking questions and trying to know will help. So we say that science represents humanity's most rigorous attempt to understand reality through systematic observation, experimentations, we do that, and then theoretical modeling. and it combines empirical investigation with rational analysis to construct explanatory what? Frameworks. So that's what they do. It's also a dynamic enterprise. So it moves, do you understand, from one stage, one thing that was probably scientific at the point in, it will be disproved by some other person. And because it's dynamic, it evolves. So we say that rather than static body of knowledge, science is better understood as an ongoing process. And that's the good aspect of it. And also, there are social institutions who look at science in a different perspective. They say science functions as what? A complex social what? Institution with its own what? Norms. It has its own values, practices that have evolved historically. Okay. And we're able to tell you that, okay, this thing you did is not scientific. When we say it's not scientific, what we mean is that you did not follow that structure or that rigorous what process to be able to achieve what. And take note that the scientific community operate through peer review. That's why the works we do to peer review, blind what review. One person, see your work. Professor Mam hasn't spoken to what? Professor Idrisu. Professor Idrisu will mark. Professor Mam will also mark independently. Even if they are wrong, we don't care. They should give their independence because we know that since they are scientists, social scientists, they will apply that same method. So most times you realize that the marks that are coming, if it's coming from good professors, the variations are not too much. It's just maybe 2 or 3. And normally when we say the variance is more than 10%, it's 10, the marks 10, then it means there's a problem. You understand? It shouldn't, if someone gave 70 and the other person gave 95, there's a problem. You get it? It should be within what? That what boundary. And also, you remember, in science, we talk about replication. So you see your data. If we pick your data, a different researcher pick your data and runs that same data, it should be getting near to your results. And that's what makes it what scientific. That is why in research, when people fake data, it becomes a problem because then you cannot what? Replicate it. Okay. And we have different types of what? Scientific method. And I mean, we have the Cartesian rationalism where you must see why this is better. Where this guy, Descartes, I don't know whether you know him, is one of the philosophers. He has his own belief system, and we'll talk about him. But these are methods that, this one is Aristotle. So we say the Aristotelian, but deductive, reasoning. And this one is more aligned to quantitative what? Work. And he said ancient approaches to science emphasize logical deduction from what? First what? Principles. With Aristotle's what? Syllabustic reasoning serving as what? Dominant methodology for there. So if you had deductive, research, inductive research, the deductive, Aristotle was more of a positivist person, you understand, rather than somebody who was a rationalist. So then we have the Baconian induction. These are the guys who believe that knowledge can be acquired through reasoning. They use inductive approach. But the interesting thing in research is this, that you get to know. Most universities do not want you to do qualitative study because this is inductive, aligned to qualitative. But the good thing is that all theories are inductive. All theories are propounded through an inductive approach. And then once that theory, like what we did, the framework, we didn't use. The first thing was to do extensive literature review and use thematic analysis to get the themes. Now, when we finished, we said that we want the thing to be exposed to a larger population, so that based on the sample from that population, which is going to represent that population, then it will get wider acceptability. That is what we did. So this is so when you hear Baconian and Aristotelian is more of what? Positive, but it's a deductive, and this is what you should do. But at the PhD level, this is the level of flex that instead of saying deductive, you can talk about Aristotelian. And if they ask, you ask them to go and pay and study. I mean, it's not your fault. You get it. So Francis Bacon revolutionized scientific methodology by advocating systemic observation and experimentation as what? The foundation for generalized knowledge. In initiating the empirical tradition. So Baconian induction believes that scientific methodology, okay, by advocating systemic observation. And you see, when you are doing research and you are doing observation, that cannot be quantitative, right? You know why? Because you, the researcher, you are the instrument. So you have a rat here and you are watching the rat. You understand? You want to see that the rat moves this way or that way. So observational research and most experimentations are from inductive research. So inductive starts with, the findings they get from the ground, and then they build theory. Deductive uses data to conclude that a theory exists. So whilst one starts with nothing, you understand, which builds the theory, the other one rather relies on the existing data. So yours is deductive. Why? Because you have the panel data. You understand? And then you use the panel data to make some informed decision. Okay. But for you, there was nothing like integrated ISO, framework 9001, 27001, 45,000, 14,001. No one, as at the time when you were doing the work, has integrated that. So through deductive and inductive reasoning, we're able to develop the framework. From where? Experts. We talk to them. You people believe that this thing will work. They said yes. Another group, you believe that this thing will work. They say yes. We ask so many questions. And then now we brought all that they have said into themes and group the major themes, the bigger ones. Okay. And then use that to restructure or to develop what we call a conceptual framework. And the interesting thing is that one of the construct was dropped. That's the interesting thing. And those qualitative guys and quantitative guys agreed that this one cannot be integrated because it has issue. Then we have the Cartesian rationalism, and Cartesian rationalism is just like the Baconian induction. And this guy emphasized mathematical reasoning and deduction from self-evident truth, establishing rationalism as a counterbalance to pure empiricism in scientific inquiry. He's saying that he's seeing rationalism, and rationalists are those who believe that knowledge can be acquired through reasoning. So he's saying that, in other words, inductive, research or qualitative research. Okay. It said qualitative research establishing realism as what? It's a counterbalance to pure what? Empiricism. And when we say empirical findings, it's based on what? Facts. You understand? And he says that, in scientific inquiry, don't take qualitative aspect out. Okay? And then you have the hypothetical deductive model. And that's one. Modern science synthesizes this approach through a cyclical process of what? Hypothesis formulation. And deductive prediction, experimentation or experimental testing, and theory refinement or rejection. Purely what? Quantitative. So these are the scientific methods. And you see that with the scientific methods, there are two here that are qualitative. All right. And the first one and the last one are quantitative. Even though they are so, the principles that they hold might not be the same. This one is coming from a purely, building of what? Formulating of what? Hypothesis. Okay. And then this guy also believed that, logical deduction from first principles. So when you hear this concept of first principle, it's Aristotle that came up with it. So just so that we know. But what I want to do do you have access to the GPT? Mm-hmm. You have it. If you have it on your phone. So you type explain Aristotelian deduction, and then Francis, you do Baconian induction with practical examples.
So, okay. Also, taking deduction, also known as syllogistic reasoning. Mm-hmm. It's a logical process in which a conclusion is derived from two premises that share a common term. Aristotle structured deductive reasoning using syllogisms, which consists of a major premise, a general statement, a minor premise, a specific statement, and a conclusion, a logical result based on the premise. Then it goes further to give an example.
Yeah, so let's listen to that.
Example, medical diagnosis. Major premise, all patients with malaria have a fever.
Okay.
Mm-hmm. Minor premise, John has malaria. Conclusion, therefore, John has a fever.
Do you get it? So it states a generic, in fact, this course of logic came from Aristotle. That I taught at the university. You understand? It's the same thing they are introduced. Okay. So you state a general premise, and then you come to specific, and you are able to draw a conclusion based out of that. I just want you to understand. Okay. So let's read. Yeah, deduct.
Okay. Baconian induction developed by Francis Bacon in the early 17th century. It's a method of reasoning that emphasizes systematic observation and empirical evidence to derive general principles from particular facts. Contrast with Aristotelian deduction method, This starts with general principles and applies them to specific cases.
Yeah.
Key features. Empirical observation, as knowledge should be based on careful and systematic observation of nature.
See, he said knowledge should be based on what? Careful, systematic observation of nature. He said observation. Now let me twist this. The reason why the Aristotelian guys believe that observation is not conclusive. Who is observing? Who did observation? Who is doing the observation? Some one or two people who are there. So in qualitative research, sometimes when you are reporting, because you want to recuse yourself, we say bracket yourself to mean that you were very fair and you were not biased. You need to state your biases first. That, okay, I am an NDC guy and constituency, so that whoever is reading knows that your bias has been confirmed. And also the person who is doing the observation, what was his state of mind at the point of doing the observation? Does he have an interest? Can we trust him? So most times when you are doing observational study, you have to profile the researcher very well for them to know who is doing. You understand? So what they are saying, we agree, observation, but who is observing? Could they take the observer to be a black man and believe what he's saying? No, because when black man observes, it's a different thing. So that's why they have a lot of issues with the Baconian system. But you see, when they finish with the observation and they realized that they said there was a research that was conducted and, you know, two rabbits, males, one was put in the, no, one. It was put with one female. They were looking at the sex drive of human beings. They realized that the guy did about 2 or 3 and was done. And they put this same male among about 5 female. And the guy was firing left, faster, left, center, and right. No, that was what this polygamy thing, that's what evolved. So, so I know you are going to complain. So it presupposes that whoever did this observation, now they are asking a question. Isn't the guy a polygamist by nature to have thoughts about that? And how many incidences of sex, did he observe? Okay, so he said, okay, we profiled the rabbit, we made sure the rabbit was fine, had not eaten anything that was spark the libido or whatever. You understand? So the quantitative people will say, don't worry. Let's bring 100 rabbits. You understand? Yes, subject them to the same test. And let's see who will find, because then we have a larger work sample. So that was where this Baconian, that is the inductive research. But most times when these people finish, we begin to now take their test and then test it to a larger population. And the more we test the theories, and then we begin to drop the variables and then refine it, then it becomes a very strong word theory. So I just want to draw your attention that yes, it's in contrast to that, because the belief is that observation and experimentation are always done unit by unit. You understand? It is not done to a larger. So this COVID-19, the drug, the vaccine, they said they tested it for a short period, and monkeys and something, and then, but ideally, if it was not also a kind of a plague that has happened, that should have been tested for about 6 or 7 months. But they did it and they start administering. Yes, but they started administering. Yeah, so finish.
All right.
Mm.
Elimination of bias, idols of mind.
Mhm.
Bacon identified four sources of human bias: idols of time, game, marketplace, and theater
Mhm.
that distort rational thinking and must be avoided.
You see himself.
Gradual generalization. Instead of jumping to conclusions from a few observations, one must collect extensive data before forming general laws.
So then he is moving back to the deductive. But we are saying that carefully. The deductive, where does it get the data to do the deductive? It comes from the inductive. Okay. So, madam, let's So let's do Cartesian, and then you also do the same thing prompt. You do the hypothetical deductive model. No, you are doing Cartesian rationality. It's the cut. Yeah, I love teaching philosophy of science.
It's interesting.
Yeah. That's the only thing that made me know that I've done the PhD. Otherwise,
And you are very good at it.
every,
You are really good.
fans number something.
Yeah.
What in that?
The Cartesian rationalism,
Mhm.
developed by the Scotch,
Mhm.
is a philosopher, a philosophy
Mhm.
that emphasizes reason as a primary source of knowledge. It argues that true knowledge comes from logical deduction.
True knowledge comes from logical what? Deduction
Innate ideas,
and innate ideas.
other than sensory experience, which can be deceptive.
You understand? So, you know, this guy who was at our place, the former IT manager before that's came. Yeah, Jack Akins or something.
The one resigned.
Yeah, yeah. So he told Mr. Lanso something, which he also told. He says experience, says experience teaches nothing. When you say that you have experience, say experience teaches nothing. That's his principle. So I delved into it. At that time, I was doing my experience teaches nothing. And I was asking, and Mr. Lanso says that, do you think that experience teaches something? That somebody says he has 10 years experience. What has experience taught that person? The person is committing the same mistakes. And if experience teaches us something, this country wouldn't be where it is.
Like about the boring we talked about.
Yeah.
And to some extent, I also agree.
No, what does it have to taught you?
Experience.
Because if experience teaches really something, it should shape the way you do your things. Example, you at work, yeah? You have gone through maybe evaluation and they have marked you down. It's expected that the ensuing year, things will improve. Ghana, we are going to go through rainy season. I swear to God, the Minister of Sanitation of whatever doesn't even do that, and we will wait, and people will die. And that will report. You understand? So either done, and I'm saying this because experience teaches nothing. It's within the context of Africans. You understand? But the white man always learn through mistakes and experience. Yes, every year.
So what has it got? This year it lays the whole town down.
You get it?
It's raised the whole city down. Both ways.
You get it? So let's go ahead. What he said was, yes.
So he's saying that he argues that true knowledge comes from logical deduction
Yes.
and emits ideas rather than sensory experience, which can be deceptive.
Yeah.
Then his famous statement for cogito or ego sum.
Mhm.
So that's Descartes' famous statement. He didn't say Descartes, it's a Descartes.
The cat.
Descartes, okay. So Descartes' famous statement. Cogito, ergo sum. I think, therefore I am. So that's the meaning of cogito, ergo sum.
Mhm.
I think, therefore I am. Reflects this approach. He concluded his own existence purely through reasoning, independent of external evidence.
That means you become what you think, or
Yeah,
also
so like we say knowledge is innate. One school of thought.
Yeah.
Also, is that knowledge is innate. Another school of thought is knowledge is acquired.
But knowledge is innate. What is knowledge?
So we're not sure another.
No, you ask. But this is the
So
reason
if
why
you are born,
scientific
so
inquiry has extended. Because Ubia Kokan we are extended.
in I think is it epistemology
Mhm.
says your with knowledge like idea really know. And one is also saying that no, knowledge is sitting somewhere, you have to apply it.
Yeah, you have to do an inquiry.
Yeah.
Yeah. So this debate is still about the rationalist and the positivist. The debate is going on. So when you begin to talk to someone, what I'm telling you, I was not taught. When you are talking to someone, and the person is talking, and he says that, may I believe that once the person begins to use that word, he is a rationalist. He or she is a rationalist. You conclude. You understand? And it helps you now to predict how the person reacts. And that's why they say that the PhD guys and the professors, they are like wizards. When you are talking, or they know your mind. Because once you begin to go on that tangent, I form an opinion. And all that I'm doing is that I'm scanning you through this lens. And then I know where you belong. It's the same thing when you go on the panel and then you have the first question that will come from the first person. Do you get it? You put the person where that person belongs, and you know how to now deal with the person. Because if he's asking that, so how did you measure? We hear the word measure. You say that this guy is a quantitative guy. I need to sit up. He's going to ask me, you get it. And another person will say that, with your study, did you know about the environment before the study? He's talking about experiential. Then you know that, hey, it's leading you towards, issues of qualitative issue, which actually is saying that when you have a full knowledge of it, it could make you corrupt your thought. So you know that that's where the person is heading towards. So these things they have.
But so in my case,
You are a mixed study. You are in the middle. We'll treat that. You see, the pragmatists, they say anything that works. But if you're a pragmatist, In fact, Criswell had come out, his old, qualitative, he's a father of qualitative study. He had not talked about the different types of what qualitative study. But most recently, about 20 years ago, he started talking about different types of qualitative study in the new release book. He talked about exploratory sequential mixed method, or he said, okay, 70% of the work is qualitative. And then 30% is what? But that's what you use, right? Quantitative. What he's saying is that if we are using this, they're expecting that, please watch. Qualitative will stay in the middle. But Criswell says that it doesn't work that way. The guy can still be a mixed study, right? And then here's quantitative, here's qualitative. And then be here. Right? It means that he's doing more qualitative than what? Or be here, explanatory sequential mixed method. Then there is also convergence. Then there's also the parallel sequential mixed method. Parallel means that in applying the quantitative and qualitative, I'm asking the questions alongside. So you, the same person, I'm asking you qualitative question. When I finish, then you you also, the questionnaire, you answer something out of it. And that is where you see in the questionnaire, there's a qualitative part and a quantitative part. Okay, that's a parallel. So he also believed that within this quantitative and the qualitative, there are other, in the middle, there are other theories and then also philosophers that are argue, like those, they call them constructivists. All right. They also went their way from the qualitative and the quantitative. They know you can, this one has its own weakness. This one also has its own weakness. You understand? So let if the thing be constructive. So they brought a constructivist, okay, paradigm that lets the quantitative and the qualitative. So let's in order not to wait. So you have the hypothetical deductive model in practice where you see that it starts from where? Observation, systematic study of what? Phenomena. That's why it starts. And then from there, it moves to hypothesis formulation, tentative explanation, propose. So in the observation, systematic study of phenomena, that one might come as a result of something we thought has happened. Okay, COVID is in. It's a phenomenon. So that's where it starts. Then it's okay. Let's study what? COVID. So I'm moving to what? Now I'm going to form what? Hypothesis about COVID. That anyone who coughs 3 or 4 times continuously might have what? COVID. So he gives a tentative explanation of that. You understand? Then he used other studies to support that. That, okay, we have had gum. We have had let him do tea for you. I mean, okay. Uncle, yeah. So it said let's then formulate hypothesis. Maybe about 20 people have been coughing, and that is my justification. Femo tea. Then you also care for something.
It's right now. Okay.
Yeah. This one is good though. Okay. There's one, the cinnamon one. Yeah. Right. Then we say prediction. Okay. Logical consequences deduced. Deduced from what? The hypothesis. Do you understand? Then we come to what? Experimentation. Empirical what? Testing conducted. Okay. You know the interesting thing? From there, you have theory development and successful one. Hypothesis what? Elaborated. Okay. So once we test, but the point is that what were we testing? What were we testing? It started from what? Observation, which is qualitative. Because we observe a certain what? Phenomenon. So that's why I'm saying that even this one, because we tested the phenomenon, this is theory development. You get it? Theory development. It means that the theory has not been what? Concretized. It has not been, formalized. And then quantitative people will pick this theory, test it, expand it to different jurisdictions. What we did with your work is that we're using that same model, and we use it for people from some people from the US. Professor Ibisu, he didn't know that he answered the question. So we are saying that the cycle process represents the idealized scientific method, though actual scientific practice often deviates from the neat model. Scientists frequently jump between stages, pursuing intuitive leaps or responding to unexpected experiment results. Now, the messiness of real scientific discovery contrasts with the orderly reconstruction often presented in textbook. You see the confusion here. He said the messiness of the real scientific discovery contrasts with the orderly reconstruction often presented. So sometimes the way things are presented are not really what they are. Okay. So let's look at. Hello? Yeah, please, I'm in a lecture. Can I call you back? I'm teaching, yeah. Can't hear. You should. So the demarcation problem, science versus pseudoscience. We'll end here, right? And I'll give you an assignment because you have the science and pseudoscience, and I'm going to send the slides to you. So the challenge. Now the demarcation problem address what distinguishes genuine science inquiry from non-scientific or pseudoscience claims. You see, we started from the fact that what we are reporting in the book. You understand? That's where we are starting. This is what rigorously science should follow. When we say science, something is what? Scientific. But what is reported in the books most often deviate from this rigorous test. And that brings the issue of science and pseudoscience. I just want you to know the connection. So the boundary has profound implication for knowledge authority, educational curriculum, and public policy decision. Since the Enlightenment, philosophers have sought criteria that can objectively separate Einstein's theory from astrological predictions. So this is the challenge. Now let's see the attempt that has been made, and then we'll look at the contemporary relevance. So numerous criteria has been proposed to solve this problem, from verifiability, that is the Vienna circle. You get to know. You can write it down so that you can Google, you can look at it from the chat box. The Vienna circle to falsification. Karl Popper, a crazy man. In fact, you can call me Popper. Yeah, I like the guy. Okay. The variance cycle to falsifiability, that's proper, to puzzle solving effectiveness, that's Kant. Okay. Each approach has illuminated important aspects of science practice while revealing the complexity of establishing definitive what? Boundaries. So the persistence of this problem suggests that science may be better understood as a family resemblance concept rather than true, necessary, and sufficient what? Condition. Now, this is very interesting. Now, it is saying that because the criteria that has been proposed to solve this problem, it's emanating from what? The Venn circle. I said you should read about that. To falsifiability, proper, and to the puzzle solving what effect in that scan. These three people. Because Popper says that any science should stand the test of what? Falsification. Okay? If we cannot falsify it, then it ceases to be what? Science. Okay? And that is why one time I heard some professor who was advancing this argument, and where he was coming from, I believe that the journalists didn't understand. The man was critiquing Nanado's one of the policies, and then the journalist, but yeah, I said, no, you shouldn't be afraid when we talk against some of these things. Because you see, in philosophy of science, then he mentioned Karl Popper. Popper tells us that any true science, okay, or true theory should stand the test of being falsified. So when it's being falsified, it shows the strength, do you understand, of that scientific empire. Yeah.
It says it's a verification principle.
Yes.
A statement is meaningful only if it can be empirically verified or logically proven.
No, they are there.
They are the
positivists. You understand? And then Popper has talked about Popper. Talk about the puzzle solving effectiveness. Can what it can say. What it can say. Mm-hmm.
It says normal science.
Mm-hmm.
The traditional view of science as a linear accumulation of knowledge.
Linear. You understand? It's linear accumulation of knowledge.
Concept of paradigm shifts.
Yes.
So normal science. Science operates within a dominant framework,
mm-hmm.
solving problems within its accepted theories.
Mm-hmm.
Then anomalies over time, data that doesn't fit the paradigm accumulates,
mm-hmm.
creating tension.
Mm-hmm.
Then when an anomalies become overwhelming,
mm-hmm.
a crisis occurs, leading to a paradigm shift.
Yes.
Then a new paradigm, a revolutionary new framework replaces the old one.
You know what he's saying?
Scientific thoughts.
Transforming scientific thought. And that's what Kuhn was against this positivist guy. You know what they do? It's the same people who said the world was flat. Now, when there was weakness, there was an inquiry to show that there was weakness in their method. They now, instead of accepting, that's the positivist, they now shift to create another framework, do you understand, to deal with that. And Kuhn is saying that no. Once we know that there are anomalies, you understand, there should be a paradigm shift, rather than creating models to validate the same theory that you are talking about, just to say that, oh, it is true. Then, Yeah, it is flat, but this thing. Then there's another model. Then they add this, and then Kant was against that, which is why Popper said that this nonsense you people are following. I'm telling you that if I take this thing through a test, I don't need another red mango to validate that it is red. I will look for a white mango. As long as I don't find a white mango, it means that the mango is red. But when I see white mango, it means that the mangoes are not red. So it means that no, he needs only one. He disarms what your theory. What believed in. You understand? So you see that this guy brought the paradigm shift that these positivists begin to move from one circle, one to the other. When they find a problem, instead of saying that this method we used was not good, something else is what introduced. Now I give you an example. Mm-hmm.
Traditional banking relied on manual risk assessment.
Uh-huh.
Then the 2008 financial crisis showed weaknesses in these models.
Uh-huh.
Then banks adopted AI-driven risk models and blockchain technology for transparency.
Mm-hmm.
And that's one example. Another example is classical statistics.
But no one talked about the weakness.
Mm-hmm.
Listen on. The risk model they were using, no one talked about it. So you see what this guy is saying. He says there should be what? A paradigm shift. But don't stay as what a positive. The same thing. No one predicted COVID, isn't it? Huh? It's COVID that exposed most of the medical response strategy or health response strategy most countries they have. That's what it's exposed. Let's look at the contemporary relevance. Now,
so there's something.
Okay.
So it says, is it Khan or Kun?
Kun. Some say Kun, yeah.
Versus logical positivism, Vena second.
Mm-hmm.
And it says, science progresses logical, the Vena second. Science progresses logical based on verification. And then Kun says, science advances through disruptive shifts.
I like that.
Logical.
So the Vienna circle are the pure positivists. And they say science progresses through what? Logically, through verification. And then Kant says what?
The science advances through disruptive shifts.
And that is
not
true.
just logical.
No.
Also, Kant's ideas are crucial in probability banking and AI, where paradigm shifts redefine entire fields. Would you like me to?
But you see the chat box is interesting. Yeah, okay. So let's look at contemporary relevance. No, the reason why I'm spending time on this is all that we are going to do. This is the umbrella that covers it. Okay, if you understand, and now when you have time, you read about Kant. You understand? You read, and you see what makes you a very good philosopher is that assuming you are doing your presentation and then you are talking about mixed method, and then somebody asks you a question. Professor asks you a question, why the mixed method? You have to come from a philosophical to ground it. You understand? I will start by saying that, I mean, it is based on my philosophical ideology. Prof, we are all aware we have two major paradigms of philosophical underpinnings in research. True what we call epistemology, how we know. And positivist says knowledge is acquired through what? Verification. And then the rationalists also believe that, knowledge is acquired through reason, right? And in fact, the positivists are those who, who were known as the Vienna Circle, all right? But the likes of Kant and Karl Popper came diffuse this to say that whilst Kant was saying that it's actually a paradigm shift, you understand, not confirming or verifying what is there. But if there's any disruption, which actually what is happening, there's a new knowledge that emerges. Okay. Popper was also saying that no, you cannot keep confirming one theory, but you need to falsify it to show how rigid the theory is. And looking at all this perspective, I thought that, taking one paradigm might be very risky. So to compensate for the weaknesses of the two, I decided to choose a mixed method and specifically using the pragmatic sport approach. And the guy sits and listens to you. Without question.
Of course, that's a very deep response.
You understand? And that's what happens when we are doing defense. When they see that the person is called from philosophical, because those things, most of the guys are forgotten. And I have to tell you, that is the rough road. You take them through that. Now, if I'm able to explain why I use mixed method, what is methodology? Because you know that where I have taken you through, when you follow me, where I'll take you to, you wouldn't like it. You get it? So me, that's what I do. You just have to, when they ask the question, you give a background. And when you begin to answer and they sit, they will see that they are educating. You are educating them. What professors do not like?
To teach them.
It's for you to teach them. So some will be excited, others will be saying that, no, it means the guy understands what he's saying. And these things are, and people go to the extent that, Kant propounded this paradigm shift in the year when he said that there is also another, because the guy doesn't want it. So you see that they will be checked. But you are saying that as them pouring. So they'll begin to know that, no, this guy is a scholar. When they say a scholar, it's in philosophy of science. Okay. So why people use mixed method is not explained because, okay, a number of people, research has shown that a number of people use what? Quantitative, and those are empirical findings. But he's asking you as a researcher. You understand? Your ideology, what made you, choose that method? That's what the person is asking. Then the last one has to do with the contemporary relevance, where we say that the demarcation problem remains urgently relevant in contemporary society, where pseudoscientific claims about vaccines, climate change, and alternative medicine compete with scientific consensus for public attention. You get understanding the philosophical foundation of this distinction helps us to navigate an increasingly complex information landscape. Okay, so I'll end there. This is what we have done is huge, and we need this background. Now, once you go and read, what I need you to do, I'm giving you the slide. So please watch this one. So you said we said we'll meet when, what was the next meeting date? Wednesday. Okay. So tomorrow, when you have time, and I'm saying that when you read these things, you will like it. When you begin to go into it, see, it will shape everything you do. In the office, everything you do, it will shape it. Your marital life. Anytime your husband is tilting to a certain direction, why you mean our problem? So you see why professors, when they get to an environment, they don't talk. They study behavior. They keep quiet. You hardly see that they talk. They will keep, and they collect as much information that they should. Okay? And they'll be able to know. Someone will look at your attitude and ask that, who is your father? That's the question you ask. Oh, my father used to do this, he works as this, he do this, then he say, what I'm known. He want to see the behavior of this behavior, where it's coming from. You get, so that's how this evolve. And I'm saying that I love philosophy of science because it helps explain. So you can read about.
What is the easiest way to love reading philosophy?
The easiest.
Taking it through scenario based.
You see, this question you have actually asked the chatbot, you will love it.
Okay.
You know the chatbot have that. Tell him that I want to. No, this one. Tell it that I want to love philosophy of science. And I want you to give me the best approach